Hi. In the last video, I worked on breadboarding out the reset circuit. I believe I have it mostly working. It's not quite reliable enough to call it definitive. But before I get into that, I've got a pretty good laundry list of things that I need to take care of. Most of this video is going to be dedicated to that, and time permitting, I will look at the clock circuit and what I need to do to clean that up. And then further time permitting, I will get into some of the bigger issues that I've uncovered from the last video. There's quite a bit that I want to get done, so let's get right into that.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
My wife Carrie has been working on a cookbook. Carrie's cookbook provides a unique culinary experience by seamlessly incorporating doTERRA essential oils into a diverse array of mouth-watering recipes, transforming ordinary meals into extraordinary dining adventures. The cookbook offers a treasure trove of innovative dishes that combine the health benefits and aromatic richness of essential oils with fresh, wholesome ingredients, making gourmet cooking accessible and exciting for everyone from novice home cooks to seasoned chefs. Each thoughtfully crafted recipe not only tantalizes the taste buds, but also promotes an overall well-being, harnessing the natural potency of pure essential oils such as lavender, lemon, peppermint, and basil. In Carrie's cookbook, she emphasizes the quality, flavor, and simplicity, guiding you through detailed, easy-to-follow instructions with beautiful photography and expert tips. Whether you're looking to elevate your everyday meals, explore new flavor horizons, or embrace a healthier lifestyle, Carrie's cookbook is your ultimate guide to enriching your kitchen and your life with the magic of doTERRA essential oils. If you are interested, there's a link in the description. Okay, the first thing I want to tackle today is the control ROM module. There's a couple of things in the Silkscreen that I want to get cleaned up. One is that it doesn't have a label on it, and I'd like to improve that. Second is the placement of the reference codes for the ICs. Those don't appear near pin 1. That's what I've been doing on all the other PCBs. It helps to identify where pin 1 is. And then I've got some rotation and a little bit of cleanup for the capacitance values that I want to get taken care of. It's all a little fussy stuff. I'm not going to reorder this PCB, but just in case someone wants to look over my shoulder, it's nice to have something that actually looks a little bit better. Apparently I took an update to KiCad, which changed some of the footprints, so that's what this is coming from. Now I'm clean. The next thing to clean up is going to be this Bodge here. Now I've updated the schematic to reflect this change, but I have not yet updated the PCB. And when I do, I'm expecting several of the footprints to have changed, and so I'll have to go through and update those as well. Okay, while I'm at it, I'm going to make one other correction here. Okay, that's clean. I chose not to populate the LEDs here on the control ROM control. So there are also resistors that were not populated and a couple of driver ICs that were not populated. And I'm going to remove those off the schematic and off the PCB. I'm noticing that the cleanup after each one of these changes is actually taking me a little bit longer than I'm anticipating. So let's see how this video goes. It may end up being longer than I expect. Okay, that's good. The next order of business here is going to be related to this header of pins. Below this PCB, I actually need to bend the pins off to the side, and the same with the mid plane in order to get the PCB inserted. There's an alignment issue there that I need to get to the bottom of. So On the control ROM control module, pin 1 sits next to pin 9 on the vertical pin header. So, but you can see here on the control logic midplane, pin 1 here is next to pin 8 of that same vertical pin header. Technically, the control ROM control module came first, so the control logic midplane is the one that is incorrect. That said, it is the most expensive PCB I've ordered to date, and I really don't want to reorder that one just for the sake of getting those pins aligned. I have much more egregious problems on the control ROM control module than I do on the midplane. So the plan here is going to be to move this header up 1/10 of an inch, which is going to, of course, step on a bunch of ICs, and those are all going to have to be moved, and it's going to create a bit of a mess that needs to be sorted through. And this is not going to be a short change, so let me work on moving that around, and then I will reset and realign the ICs, and we'll see how that works out. Okay, let me start by moving the module name down, and then the pin header itself up. And that's going to break just a whole bunch of stuff. Okay, I'm not quite the fan I need to be on how this is working out, so I am going to copy a bunch of stuff out, or at least move it out. All right, now let's clean up this mess a little bit. After moving everything in, I assess my strategy. First order of business is to connect up the instruction bus, which goes right up the middle of the PCB. Next, I connect up the AB select and then the outputs to the lookup address into the control ROM modules. Next, I connect up the outputs to the counter ICs. Those need to go both to the 74HC157 multiplexers, as well as out to the program ROM for copying its contents into SRAM, a future task. Next, I interlace power and ground. Finally, the last few control signals and a cleanup to make sure that design rules check passes. Okay, that's clean. The next thing to look at is going to be the reset hold signal. Now, originally I had reset hold coming off the control ROM control module, and the reset module renamed that signal so that it could be in charge of the reset hold. And so now what's coming off the control ROM control is now called copy hold. The reset module schematic has this correct now. But now I need to go back and take care of the control logic midplane and the control logic control to make sure that those signals are now named properly. I'll start with the control logic control. And then the PCB just to make sure that I didn't create any problems. Nice. Now the control logic midplane. And then once again, I have to double check the PCB. I've got to update a bunch of footprints. Let's do that. And now I've got overlaps. Okay, very nice. Next, I have a discrepancy on the reset module. The discrepancy is between the emulator and the schematic. The emulator has a high-speed clock, which is known on the schematic as the system clock. The emulator has a system clock, which is known on the schematic as the reset clock. Well, the schematic definitions are not quite as robust as I would like them to be, so I am going to change them to match the emulator. Okay, that's good. And I'll remove these comments. The control logic midplane has a Silkscreen error here for control ROM F. Also up here in the corner, the decoupling capacitors are way too close to each other and way too close to the pins here, making it almost impossible for me to solder these up. I'm going to rotate these. Again, I'm not going to reorder this. This is the most expensive, but if I do end up having to do that for some reason or another, at least it will be ready to go. Let me rebuild the teardrops and then run one last rules check. Very nice. The last issue I want to take a look at is related to the LEDs here. This first LED here is used to indicate while the system is in reset, so in other words, when I'm physically holding down the reset button, and until the copy is completed over here on the control logic. Once that copy is completed and my microcode is loaded into SRAM over here, this second LED then indicates that it's clocking its way through the circuit in order to make sure that things are cleared out in the fetch and instruction register. And then finally, the third LED is to indicate that the system is in running mode. The fourth is unused. The problem is that the transition from this first LED to the second LED happens before this copy is complete. On reset, this transition happens while this is still copying, and this is not working properly. Now, the transition from copying to, while it's clocking those additional cycles to clear out all the registers, to running mode, that's happening properly. So here is my 74HC74. Now, while the not done signal is named correctly, there are some challenges here. Its input is the copying set reset latch, indicating that when this is high, I am copying and therefore I am not done. And then, so this would then be low when pin 8 goes high, meaning that I'm done. Pin 9 would go low, meaning that I'm not done. However, on reset, the reset signal triggers not done to go low. I'm not done, or I am done, and then immediately on the first clock tick or setting indicating that it is in the correct state. So ultimately what I need to do is I need to swap the signals for pin 10 and pin 13 in order to get that to work correctly. Now the output on pin 9 or pin 8, I should see a short tick, and that's going to be related to how this raw copy clock is coming in, how the duration of that. So using the oscilloscope, I want to go check pin 8 and or pin 9 on that 74HC74 on the PCB. Okay, let's see if I can't capture this. My yellow trace is going to be on pin 13. Now that is the reset signal. And as soon as that signal goes low, I am thinking that pin 8 should also go low to indicate that the copying is not done. Now I've got my trigger set on the rising edge of the reset signal, and when I power this on, let's watch the timing of that. So what am I seeing here? The yellow trace is my reset signal, and that should, as it's coming high, the done signal is coming low. The done signal should be going low at the same time that the reset signal is low. So that's actually not correct. And I believe I need to swap out pins 10 and 13. To do this, I'm going to have to pull this IC because I've got this bodge that's kind of in the way here. And so I'm going to have to pull this IC off, bend the pins, reattach the IC, and then connect the pins themselves to where they really need to go. So there are 2 pins that I need to lift and reconnect. Pin 13 here needs to be lifted, and I will end up needing to connect that to VCC. VCC is conveniently right there, so I should be able to just simply bridge these 2 pins. Pin 10 here I need to lift, and that needs to be reconnected back to the reset signal. Now currently the reset signal is under this pin on this pad, but I also have it available to me here on pin 4, so I'm just going to run a Bodge wire across to pin 10. Now my problem is the proximity of this Bodge wire here to this pin, and if I gently push that out of the way, I might yet still be able to get a soldering iron in there and maybe use the tip of my tweezers or forceps here to lift this pin. I'm trying to see if I can get under it. That might be a bit of a challenge. We'll have to see how that goes. I may or may not be successful with that. I might actually have to remove the entire thing. Let's start by heating up the soldering iron and see if I can't get my more easily accessible pin number 10 lifted here. That actually feels like it's coming up, except when I slip. Okay, let's try this with the blade. Maybe a little bit of solder on the soldering iron. Maybe that'll help to melt that. As you can see, I'm doing a better job of melting the solder on pin 11 than I am on pin 10. Well, that is lifted a little bit. Now the question is, did I damage the IC? Let's see if I can get some of that solder off of there. Okay, that is separated from the board now. Okay, that is properly separated. Now, can I get this next one? Okay, that one is lifted as well. That actually went much smoother. Okay, let me see if I can pull that up just a little bit more. Nope, that's fastened itself back down. So the next stop is Bodge wires. Okay, I did a little fiddling off camera, and I very clearly here have separated the solder from the pad, or the pin from the pad on both of these. Now, like I said before, this pin here, pin 10, can be routed over here to pin 4, and I'm going to do that first. It's going to be a very short Bodge wire. This pin can be routed here to VCC, but VCC is also available here. I'm afraid this is going to be too short unless I put a very heavy, relatively speaking, heavy gauge wire in here to do this connection. So I'm going to think a little bit more on this. I may go from here to the capacitor, or I may do just something very short and very exposed between these 2 pins. I'm going to start here though. Okay, I spent a minute cutting and bending up this Bodge wire. Now this will go in this direction. Nope. In this direction, such that the shorter bend here goes to this pin, and the longer bend there, will go to pin 4. I'm going to start by trying to take care of pin 4 first. We'll see how well this goes. This wire is so small, I don't expect it to cooperate. Okay, well that's one side. And I'm not going to call that a reasonable quality joint. I can probably do better. It's still not a quality connection, so what can I do here? Let's get a little bit more flux on that. That looks much better. Yes, I'm liking that much better. Okay, now the other side needs to go to this pin right here. That's solid, and even though it's out of focus, that was not reattached to the board. So that is a good bodge. Okay, this last one I'm going to go with this little teeny tiny piece of wire here to connect these two pins. Of course it'll be exposed, but that should not create any issues. So let's see what we can do with that. Okay, that's one spot. Now here's the problem is I'm going to need to solder the second one on without disturbing the first. And that, I believe, is going to be a rather big problem. Given how close those are together, the best thing I'm going to be able to do is hold on to it. And that might have gotten it. That looks like that worked. And once again, yeah, I did not fasten that down to the pad. So that will work. That will work. Next up, let's plug this back in. Let's see if I can't redo that test and get the signal that I am expecting. Okay, I've got the oscilloscope set up very much like it was before. The yellow trace is going to be my reset, which I am going to put on pin 4 now because pin 10 is now very fragile. My done signal is going to be the cyan trace, and when I power this on, you can see as the reset is going high, the done signal is already low. So where do I need to trigger from? I need to trigger on power coming high. So that is going to be a rising edge on the yellow trace. Let's give that a shot. So once the yellow trace goes high, my expectation is that the cyan trace goes low. It's low, it stays low. Now when does it transition back high? I don't know that I've got a good connection there. So let's find the transition of the cyan trace back high. There it is. And then if I get my clocks in, it now transitions. The other thing to look at here and watch is going to be the LEDs. Now recall that the first LED is supposed to be on during reset, meaning while the reset button is being held or the power supervisor is holding this in reset until all of this has been copied. In other words, that done signal comes high. The second LED is going to be when I am clocking the fetch and instruction register to make sure that they are clear. And then the third LED is supposed to be running mode. The fourth one is not used. So let's watch that here as I power this back on. So the first LED comes on and stays on. I am still copying. That's now done. I am clocking, but my clock is not actually running, so let's turn that on. And almost immediately it goes to running mode. Let's slow that way down. So now I've got a much slower clock. We'll try that again. Something happened when I hit the clock on that one. I'm not exactly sure what that was, and I don't know that I can duplicate it. So it was copying. I turned the clock on, and yeah, it's transitioning on that clock, and I do not understand why. If I do a manual reset, that's not holding. Well, my thinking was that that pin had been pushed back down as I cleaned it so that it touched the pad, and that's why I was getting crazy signals. I went to pull it back up and this happened. So now I have to unsolder that whole thing and redo this bodge. Yeah, this is fun. The first order of business here is to get the broken IC off the PCB. Then I need to take a minute and clean up the pad so that I've got a clean starting place for the new IC. Next is the replacement IC. I'm going to bend these pins up before I attach it to the PCB so that there's no connection there. I go about this using my normal procedures, except I do not solder anything to those two lifted pins. Next are the two bodges. The first of those is the reset signal. I opted to reuse the existing bodge wire. Second on the list is pin 13, and I went ahead and extended that all the way over to the capacitor. Now for a retest here. Now I have not yet powered this on, so I have no idea what to expect here. I did do a couple of sanity checks though. I did double check power and ground to make sure that I did not short those together. I did double check my signal here to make sure that it wasn't connected to VCC. And I did double check this signal over here to make sure that VCC and reset were not connected to each other. Both of those latter tests imply that I did not reattach these pins back down to the PCB. So let's see what happens. Cold reset almost worked. And I say almost because I have a couple of LEDs that did not make it on, which means that the shifting itself was not good. Now that said, I also had a problem with a warm reset, and I still have that problem here. So this LED is not supposed to be lit until the copy is complete. So let's redo that last test. So when VCC comes high, which is where I have the probe 2, the cyan probe, as it comes high, done should remain low, and it should remain low until some portion after that. Okay, that looks reasonable. Now for the warm reset. For that, I am going to go with the reset pin here on pin 4. I need to change that to be the falling edge. Let's see what happens here. And they are falling together. Let's take a look at the next pin up. That is not done. And I'm expecting that to operate like that. So that is the correct signal. Let me go back to the rising edge of the reset signal. And that is correctly remaining not done. This is done. And that is correctly remaining done. So let's find out where that is a rising edge of channel 1. That should not be rising yet. So let's try that again. That transition is happening at the right time. Let me go back to not done. And try that again. So keep a close eye here. The signal is correct. The LEDs are wrong. And that is falling at the correct time. So that tells me then that I actually have a problem on the reset circuit, and that's going to be related to the LS123 and how those how the multivibrator is being triggered. It's being triggered incorrectly. Before I dig in and troubleshoot that, I want to clean up the control ROM control circuit, the schematic, and the PCB. Although the changes are very simple in the schematic, the changes actually take place in a congested portion of the PCB, so it takes a little bit to get everything lined up right again. I want to start by taking a look at the warm reset. I believe that that same change is going to work on simplifying this cold reset circuit and make things a little bit more stable, more deterministic. If you take a look here in this section, I have a push button reset which has not been debounced. And that ends up drawing the reset signal low, but it could bounce back high again. That's a point that I need to keep in mind, because as I go here to the state, this reset circuit is an input into this NAND gate. The reset signal itself, I could hook up to this clear, and that would in theory fix the problem, meaning that when reset goes low and then bounces high momentarily, I do not get this transition from resetting to clocking. By holding reset low and attaching it to the clear until copy hold can come low, that should in theory solve that problem. But I want to go a bit of a different route here. I need to debounce that reset signal regardless to make sure that it operates properly. And that could in theory do that. But I want to go about it using a different power on reset circuit. Alright, Adam, what do you have on your mind? Well, when I was working on my EEPROM replacement using SRAM and a battery backup, it was suggested to me that I take a look at the MAX 704 IC. Now, this is a DIP package, very easily used in breadboards. I have a bunch of them that I purchased in order to try on my EEPROM replacement. And so I've got a few of these available. I'll solder this in as a through-hole component. Why is this better than this? Well, if I look at the banner specs for the microprocessor supervisory circuit with battery backup, it has a 200 millisecond pulse reset width, which is partly what I'm trying to engineer with all of this mess here. It's got a debounced TTL and CMOS compatible reset, which I just identified I need to fix a debouncing problem here with this reset button. And ultimately, I believe what it's going to do is it's going to fix my debouncing problem, but also fix my power on delay problem by managing these delays. It's already built into the IC 200 milliseconds. So a lot of the mess here that I've created associated with trying to get a clean reset can go away and just be managed by this IC. And the first thing I need to do is get rid of my LP3470. This was the very first video I did, was to solder this on. And so I'm going to have to retire that and then get rid of all of this mess up here, which just creates an absolute over-engineered, not working nightmare. Let me clean that up. Thank you to GC Ewing for the comment. I'm no expert, but the comment caused me to step back and rethink my solution here. After cleaning up the old mess, I'll start with the basic power and ground. I'm not intending on using the battery here, and the datasheet says when not using a backup battery power source, ground VBAT and connect VCC to VOut. Now, I'm not planning on using VOut, so I don't see that I really need to connect VCC to VOut. It's just going to be providing voltage on the other end of a MOSFET. So I'm going to omit that, but I am going to ground VBAT. VBAT is on pin 8. Next is the push button for master reset. Master reset is on pin 6. The datasheet also talks about using power fail to assert the reset, which would duplicate the functionality of my LP3470. And the way that you do that is you connect power fail out to master reset. Power fail output is on pin 5. Pin 7 is reset. And there is some commentary about making sure that reset is valid between VCC equals 0 volts and VCC is equal to 1 volt. And that is by putting about 100K resistor to pull that signal low. This resistor R1 here. Okay, so I will hook up the reset signal back up to the rest of the circuit. And then I'm going to replace the 10,000 ohm pull up resistor with a 100,000 ohm pull down resistor. The last pin to hook up is power fail input. Now that's on pin 4. And the power fail input, if the voltage goes below 1 1/4 volt, then power fail output signal goes low. So this voltage divider here, R1 and R2, needs to be set up so that if my 5 volt line drops below whatever threshold, let's call it 4.8 volts, so that I divide 4.8 volts such that if the power fail input goes below 1.25 volts, it will trigger the power fail output. I need a voltage divider with a couple of resistors, and that's going to require some math. Okay, after some calculations, what I came up with was if my R1 resistor was 3,300 ohms, my R2 resistor was 1,200 ohms, both of which I have in stock, then my threshold voltage will be 4.6875 volts. That would result in a 1.25 volt input on the power failure in pin. So that's actually a good number, I think. Let me get those two resistors out and we'll get those plugged in. Okay, R1 is 3,300 ohms. R2 is 1,200 ohms. Okay, I'm ready to give this a shot. Place your bets. Well, that worked. And reset. That worked as well. But I do see something that's not quite right yet. My transitions here between the LEDs are still not accurate. Again, this first LED should be lit while this is still copying. And only once it's done copying should it transition to the second LED. The transition to the third is accurate. So overall, this is now resetting properly on cold reset. On warm reset, it's always been behaving accurately. So I'm good there. Now, I did intend to have this resolved, and it is not. So I'm going to move that to the next video. Well, I didn't solve every problem, but I got a vast majority of them taken care of, and I'm very pleased to get to this point. Like I said, there are some issues. I do still have that transitioning from the copying to the clocking LED happening far too quickly. I actually do know what the problem is there. We'll get into that in the next video, and I apologize for the cliffhanger here. Also in the next video, I'm going to take on the clock circuit. There's a lot that needs to be cleaned up now that I've got a properly functioning reset circuit, and a lot of that was built into the clock circuit, so I'm going to have to strip that down and make sure that I'm good to go there as well. In the meantime, it's Christmas Eve here as I'm wrapping up this video. Enjoy your time with your family as you celebrate whatever holiday is yours. Be kind to each other. We'll see you next year.